Hello, welcome back to Cracking the Cryptic, and I am ploughing on regardless, despite the fact that there is an absolute hammering spree going on behind me in the building next door. So I'm going to put up with that and have a look at a new set of rules in a new puzzle today. So looking forward to that. Don't forget, we will be streaming again later in the week. We will go back to the vessel, the Obra Dinn, and see if we can work out what happened there to devastate it so badly. Made some progress last time, but there's lots more to go, I think. So looking forward to that. On Patreon, we have, of course, our November monthly reward. We updated some of the attachments yesterday, so I don't think anything that mattered very seriously, but some puzzles that had the wrong picture on, for instance. Anyway, those are all on Patreon for our subscribers. We have got a number of entries in now. Well done to anybody who got through those already. It is a tough set. We will be drawing a line on the 20th and awarding a prize at that point to one lucky winner. Now, that is on Patreon, along with Simon Solve of Zetamath. There are all our apps, and they're all linked under the video. You can look at them in the description field and go to Discord there as well, and Sven's SUDOKU PAD. So do consider trying all that out. And the merchandise, getting very popular in the run-up, sort of the early run-up to Christmas anyway, but that is proving very popular. Not surprisingly, as some of it says things like bobbins and knowledge bomb and, yes, bobbins, for instance. Exactly. So there we go. Now let's have a look at this puzzle. This has come in from Andreas V, and it's called Wedged Sum, and it's a new idea, I think. So there are a number of green cells in the grid. We've got normal Sudoku rules, of course. Digits in a green cell and the next green cell in the same column or row must sum to a digit in one of the cells between them. Now let's just explain that. If we look at this cell here, the total of that cell plus that cell must be the digit in one of these two cells. So say that was a 1 and that was a 2, we would have a 3 either there or there. Now that would also apply between these cells. So if that was a 1 and this was a 6, we would have a 7 in one of those three cells. It doesn't apply if there's a cell in between. It's only referring to the next green cell in the same column or row. So the same thing wouldn't apply as regards those green cells. This one doesn't have a friend in its row, so it's only looking vertically to that one. But absolutely intriguing. I haven't seen a rule set like that. Don't know how that's going to make this work out, but do give it a try on the link under the video. You can judge from the video length, if you like, how hard it's going to be. Not an option available to me. But give it a try and see how you get on. I'm going to start now. Let's get cracking. And what do we do? Right, this cell sees a 4 and a 5 and another 5. So it can't be 5 or more, or it would add up to 10. Well, I mean, it can't be a 5, obviously. But if it was a 6, it would add up to 11. We can't put 11 in a single cell, so this is going to be 1, 2, or 3. It's not 1 because its total here with the 4 would be 5, and we've already got a 5 in the column. So it's 2 or 3. That is 6 or 7. I think this is 7 or 8, given that 5 as well. And down here, there must also be a 7 or 8. Actually, it can't be here, or it would be the same digit that was there. So it must be here, and it must be an 8. No, it must be here. That's what I mean. Sorry. It can't be here because it would be the same digit as that. So it must be in this cell, 7 or 8, and we don't know that it's an 8. Now these, that's seeing a 5 and a 4. Again, it can't be higher than 3, therefore. It can't be a 1, or this would be a 6. So it's 2 or 3. That is 7 or 8. This again, 1, 2, oh, it could be a 4 this time. We could get a 9 in there. Yeah, it's looking around for these relationships. This is low because of that 6. Ah, and we can't have a 7 in those cells because there's already a 7 there. So again, this isn't a 1. That's a 2 or a 3. And now we've got a pair? Okay, that means this can't be 2 or 3, but it doesn't mean much else about it. This can't be 1 or 4 because of Sudoku rules. It can't be 5 because the 9 there, well, both of these 9s prevent that being a 9. So again, that's 2 or 3. This is now 6 or 7. I think we've used the high value. No, there's another one here. 6 plus that. That must be 1 or 2 because this can't be a 9. So that is a 1 or a 2. That's 7 or 8. We've got another pair in a box. And I don't know how to use that. We've got a pair in the row as well. 7, 8, 5, 9. So that also can't be 2 or 3 because they've been used in the box. Oh, this is 1 plus 2 or 3. So there's going to be a 3 or a 4 in those cells. That's not, I can't even pencil mark that. Oh, come on, there must be something that is going to pop open a bit more. That plus 2 or 3 is one of those. I don't... Oh, right, yes, this is good. That plus 1 is either 7, 8 or 9. So this is 6, 7 or 8. And that's a big number. So now this can't be higher than 3. And in fact, we've used 2 and 3 in the box, so that's a 1. Somewhere here we have 7, 8 or 9, which I can't pencil mark. But that being a 1 makes this a 2. Now we need a 3 between them. That's got to go there. This has become an 8. That makes this a 7. That makes this a 2. And now all the work we've done in terms of pencil marking is really paying off. 3 and 1 there. So there's going to be a 4 somewhere here. Oh, look, this is a 1, 4 pair, actually. So that's not the 4. 8 sees that cell, which becomes a 7. That sees this cell, which becomes a 6. We now know this is a 2. That makes both the 6 and the 7 work. This is a 3. So we need a 9 in here somewhere because of 3 plus 6. Now, what about down here? Or up here? I'm not too sure. This can definitely be a 6 and will have been answered already. I can't. Oh, 2 and 5 is 7. So this is 7. Sorry, didn't spot that when it was glaring. That's now not a 7, but 6 or 8 would make one of those work. 6 would need a 7 there, 8 would need a 9 there. So that's not actually resolved. What about this? It can't be 1, 4 or 7. Actually, it also can't be 3 because they can't have a 4, and it can't be 6. So it's 2, 5 or 8. If it's 2, that's a 3. If it's 8, that's a 9. But if it's 5, one of these is a 6. 5 plus that is not resolved. I'm missing something here. Right, let's have a look at this 3 again. 1, 6, 7, 2, 9. Oh, that's now a 4. The 3 possibilities, 1 and 6, have gone. Right, so that's not a 4. Now we know where the 4 is between this 3 and 1. This must be a 9. No, hang on, that's not necessarily true. In fact, it's definitely not true. 5, 8, and 9. That's 5 or 8. Right, now this could be a 1 to make that work, or a 2, 5, or 6. Oh, that's not helpful. Right, disappointing. What have we got here? This is 8 or 9. Oh. Yeah, that's just not getting resolved. Oh, what about with this? 3 plus 2 is 5 would work. 3 plus 5 is 8 would work, except if that was 5 and 8, what happens to that cell? Impossible. So it's got to be 3 plus 2 is 5, I think, and that fixes 8 and 9 there. Now we've got an 8-9 pair here. 5, 2, 7, that's a naked single. 6, that's what I'm trying to do, and then there's a 1-3 pair. Now 2 plus that, pretty hard to determine. These two are so far apart and will have so many digits between them, they're not very helpful at all. I don't know quite. It's a matter of continually finding where to look next. By Sudoku, that is 5, 6, or 8. And in fact, that is 1 or 5. Oh, this is now 3 plus either 1, 2, or 4. So that's a 1 or a 2. And what about this? It can't be 3 plus 1 or 2 because 4 and 5 are locked up there. And it can't be 3, 4, or 5. It must be 6, and that 9 is the solution to that sum. Now that's a 6, though. This becomes an 8. That gives us a 9 here, which works for the sum. This and this both can't be 8. So either 1 plus 2 will give us a 3 there, or 1 plus 5 will give us a 6 in one of them. That's not so helpful. That's 1 or 2. 8 in the column is there. There goes the drilling again. I hate it. That's 1 or 3. These are from 1, 3, or 9. There's a 4 down there. Right, 6 here plus only 2 or 3 to give 8 or 9 here. 6 plus, this can't be a 4 similarly. Oh, it also can't be a 2 because of that. Now that's a 1, 3 pair in the row, so that is a 2. One of these is an 8. It doesn't really help with that still. This actually sees 5, 6, 7, 8, 9 in the box, 2 and a 1, 3 pair in the row, so that is 4 now. That's 2 or 3. Can we resolve this yet? Yes, that can't be a 2, or it would have a 3 there, and this cell would become impossible. So that's a 5. That makes this a 6 by Sudoku rather than by the sum. That's 2 or 3. That's all not finished. Okay. 1, 5, and 8. Right, this now goes with a 5. Feels likely to be a 3. No, it can't be a 3. It's got to be 1 or 4. No, it can't be 1 because these can't be 6. So that's a 4. And this must be 9. 2 and 4. That's going to make this 6. Suddenly everything's getting answered. We've got an annoying triple there. What about this? It adds on to 1 or 2 to give one of these numbers. Well, it can't be another 1 or 2, or they'd add up to 3. It can't be 3, 4, or 6. It can't be 7, 8, or 9. It's got to be a 5, I think. And then we get 6 or 7 here as a result. But I don't know that yet. But that's not a 5 now. This is a very cleverly done puzzle, actually. That is a naked single 1 now. Sees 2, 7, 8, 9, 5 in the column, 4, 8 in the row, 6, 3 in the box. Yes, that does work. This can't be a 2 because that's a 1, 2, 3 triple. Right, 5, well, it doesn't tell us. Those don't tell us what that is in the green cell. But 1, 2, 3 triple, 7, 6, 5 there. We've got a 4, 8, 9 triple there. A 1, 5 pair down here. This is a 3, 6, 7 triple. 2 and 5 make 7. 2 and 4 make 6. That's all resolved. 6 and 2 make 8. We now know where that is. That's the 8. This is a 9. It's all it can be. Now along the bottom we've got this 1, 3 pair. The the only place for a 9 is here. That gives us a 9 there. We can do the 9, 4, 8 triple. Hasn't resolved this 1, 4 pair. 5 plus 1 or 3 gives 6 or 8. 1 or 3 plus 6, gives 7 or 9. So that's got to be a 7. That's useful. So we get a 1 there. Right, that's going to disambiguate everything in these middle sections. 2, 3, 1. There we go. That 1 sees a 4, 1 pair. 7 has become there. That triple's done. This 5, 1 pair is done. I think we're finishing off now. What an interesting form of a puzzle. 8 and 6 there. Thank you to Andreas V for sending this. 6 and 7. I mean, not too hard, but really interesting rule set. Playing around with things that we don't normally see. 3 and a 4 to finish off, and that looks right. Wow, very interesting indeed. So I hope you had a go at that, because that's entertaining. Didn't take all that much time, and it didn't require an enormous break-in or anything. You just had to be careful with the possibilities, especially in the middle. But a very interesting puzzle, and I'm glad Andrea sent it. Hope you had a go at it. Really quite manageable today, and hope to see you again tomorrow for more Sudoku. Bye for now.